Hi, Gary Mrzinski here again, and we are going to continue with Chapter 5 of the Macroeconomy today. And in this relatively short video, we're going to be discussing the difference between real values and nominal values. Whenever we measure something in terms of dollars, if dollars is the unit of measure, and let's face it, in economics, a lot of what we measure is measured in dollars, the complicating factor is, as you make those measurements over time, there's also inflation that's happening over time, which can distort those numbers for the purposes of your analysis. So if you imagine, let's talk about your income. Imagine that you know what your gross income was each of the last 10 years. Imagine that you have a list of values, so it's measured in dollars, and you would like to know how much your income has grown. Those are nominal dollars. The problem is there is inflation that has been happening each of those 10 years, and that changes the value of a dollar. So let's just take 1 year. If last year you made $50,000, you got a raise this year, and now you're making $52,000. That's a 4% increase, right? You probably feel pretty good about that. But what if I told you there was 3% inflation between last year and this year? Now, how much did your purchasing power really go up? In other words, how much did your real income go up? Really only 1%, right? A 4% increase in your nominal income, but there was a 3% inflation, which means overall level of prices rose by 3% from 1 year to the next. Then your real income only has gone up by 1%. That's what we're doing here, and that's the point. It's important for GDP also because we measure GDP because we'd like to know what's going on with our economy. The goal is for us to have economic growth and to have a certain amount of economic growth. Well, if, just the same example, if GDP goes up by 3% 1 year to the next, and you feel good about that, but there was 2% inflation during that time, then two-thirds of that increase was due to just prices going up. And only 1%, one-third of that growth, in other words, was due to actual economic growth. So that's what we're doing here in this chapter, and we're going to learn how to do it. It's based on price indexes. And there's a bigger focus on this when we get to the chapter on inflation. But we'll briefly explain what a price index is and how we use them to convert nominal values to real values. So nominal GDP is GDP measured in dollars of that year, the year that the measurement was taken. Real GDP then is when you convert those nominal values to values of some year that you choose. It could be the current year, and usually we choose the current year. So if we'd like to compare GDP in 2000 to GDP in 2020, we have a better feel for what the value of a dollar is today. So it would be more useful to convert 2000 GDP to dollars of 2020 and then compare it to 2020's GDP and see how much growth there's been. That's the idea here. So you're going to choose 1 year and convert the dollars to dollars of that year. So then you can compare the two numbers, and it's a more useful comparison. And we'll do plenty of examples of this. Now, a price index has a base year. Usually it's the year that the price index was established. And let me mention that there's lots of different kinds of price indexes depending on what it is you're converting. There's one just for GDP. It's called the GDP deflator, and I'll show you where those values are in your textbook. There's also one that you may have heard of called Consumer Price Index. This is measuring changes in prices of consumer goods and services only. So it's usually what you see in the news that the inflation rate is based on. Usually that's based on Consumer Price Index. But if you're converting GDP dollars, the price index you should use is the GDP price index, or the GDP deflator it's called. So there's a base year. The base year for that particular index was, and I'm looking in the chart right now, 2009. The price index in the base year is going to be 100, and then it changes from there. Here is the formula that we will use to convert nominal values to real values. And it is the nominal value that you're looking to convert is in the numerator. So that is the nominal, in this case, nominal GDP in some certain year. And then in the denominator, it's a ratio of price indexes. As I said, we have a price index for every year. And that is a reflection of the overall level of prices in that year. What you do is you're converting from dollars of some year to dollars of another year. So this ratio that you see in that denominator is the price index in the from year divided by the price index in the to year. Now remember that the price index in the base year is always 100. So if you're ever asked to convert to dollars of the base year, then you would insert 100 in where you see the 2 year, price index sub 2 year. And as I said, we'll do plenty of examples of this. Now let's do a problem using the formula that you just learned about. And you're going to be using data, you're going to be looking up data from the back of your textbook. The very last 4 pages, T-1, T-2, T-3, T-4, are tables of economic data that we're going to be using from this point on. T-1 shows you nominal GDP going back in time, nominal GDP by year. You're also going to be using page T-3 to do this problem because that's where you find price indexes, the first 2 columns. The first column is consumer price index. We'll talk about that in a little bit. We're going to use, for these problems, the GDP price index, which is referred to as the GDP deflator, same thing. That's in the center column on page T-3, towards the bottom. That's the GDP deflator. That is the appropriate price index to use to convert GDP numbers. All right? So what we want to do is convert 1991 GDP, nominal GDP, to 2020 dollars. The reason we might want to do that is because it helps us to understand a little bit better how much the economy was producing way back then, if we express that number or convert it to today's dollars. So this is going to inflate the number because what it's doing when we use this calculation is it's adding in all of the inflation that happened over those years, makes it a larger number. All right, so here we go. In the blue, I'll read this nomenclature to you. 1991 real GDP in 2020 dollars equals, and in the numerator, the first thing we need is 1991 nominal GDP. You're looking on page T-1, the first blue page. And you can see the first column is the year, the second column is the nominal GDP values. And these are in billions. So you can add another 9 zeros. Or just know that a trillion is 1,000 billions. So this would be 5,995 billion, which is like saying, and if I round this off, I would say 6.00 trillion is what this is. All right, but we're just going to work in billions. Leave the number in the form that it is in the table. And just know that your answer is also going to be in billions. All right, so our numerator then has 5,995 in it. In the denominator, here's that ratio of price indexes. The from year divided by the to year. You're converting from dollars of 1991 to dollars of 2020. So the price index for 1991 is above the price index for 2020. And then that gets in parentheses. You calculate that number, and that's your denominator. All right, so you look these values up in the table. Again, this is on page T-3, table T-3, and it's the center column towards the bottom. That's the GDP price deflator. Look it up for 1991, 65.8. Now look it up for 2020, the most recent year that we have data for, 113.4. So then in the denominator, you have 65.8 divided by 113.4, which is 0.580. So then your answer is 5,995 divided by 0.58. So when you divide by a number that's smaller than 1, it makes the number larger, right? Sure enough, 10,336 billion. billions. I should say billions. 10,000 billions. So that means if you want to express this in trillions, it would be 10.3 trillion. Now here's another exercise of the same kind. You're going to use the same formula. Let's see if you can do this. And you can pause this video once you think you know the game plan. And see if you can look these numbers up, see if you can do this calculation, and then check your work. Okay, so what we're doing here is we're converting 2019 nominal GDP. That's the most recent GDP number that we have available to us in table T-1. We're going to convert that to $1982, so we're going back in time. So you can see that's going to make it a smaller number because we would be taking out all of the inflation that happened between 2019 and 1982 to express this number in $1982. It's going to deflate the number. All right, but you just need three values. You need 2019 nominal GDP. You look that up on page T-1. And you need the two price indexes. The from year, in this case, is 2019. So that's on page T-3, center column at the bottom. Look up the price index, the GDP price deflator for 2019. Look it up for 1982. And then see if you can plug them into this equation and get the same answer that I'm getting. Again, I'll remind you that GDP numbers in table T-1 and T-2, which is real GDP, they're all in billions. So there's another 9 zeros after those numbers. But I like to think in terms of trillions because they're all, they're shown as thousands, but they're thousands of billions. So the answer here, as you can see, if you are able to get it, is 9,371 billions. So that really means 9.37 trillion. This is just one more exercise using that same formula, and it's asking you to find different values though. Now the way this is set up, you have a column for nominal GDP. So that's GDP measured in dollars of the year that the GDP was created. And then there's a column for each of the years, real GDP. That means each of the values in column 2, nominal values, are converted to real values based on one of the years. And if you look at the price index, which is column 4, you'll usually see it either there or maybe in the title of the table. It'll tell you what year they're using as the base year. And you can see 2009 equals 100. That means the value of the price index in the base year is 100. That means all of the real values are converted to dollars of 2009. That's what that means. So all of the values in the third column are the second column values converted to dollars of 2009. All right, so the first one you should try to do is for the year 2000. What was real GDP? So then you're looking for 2000 real GDP in 2009 dollars. And you can see they give you the price index for 2000. The price index for 2009, since it's the base year, is 100. This actually makes the calculation pretty easy. So go ahead and try to do that. Use the same formula we've been using and see if you can find that. Once you're done doing that, do the same thing for 2009. When I teach this in the classroom, I usually say to the students, anyone that can tell me 2009 real GDP in the next 5 seconds gets an A in the course. 5, 4, 3, 2, 1. And they don't have enough time to figure out that in the base year, if the price index is 100, then the real value is the same as the nominal value in that year. So real GDP in 2009, it's like saying 2009 real GDP in 2009 dollars is 14,417.9. And then if you really feel energetic, you could try to figure out the value of the price index for 1995 using that equation. There's just a little bit of manipulation. Plug all the numbers in that formula that you know, and then solve for price index of 1995. This graph shows you how nominal GDP and real GDP compare to each other. And you can see that the base year for the real GDP calculations in this case is 2012. And in fact, that's what it is on table T-2 in the back of your book. All of those real GDP values are in 2012 dollars. All right, so then if that's the case, then any year forward or after any year after 2012, nominal GDP should be larger than real GDP. For example, if you wanted to find out what 2020 real GDP is in 2012 dollars, that would make the number smaller, right? The real value would be smaller than the nominal value because you're expressing 2020 nominal GDP in dollars of a prior year. So you're taking out the inflation, you're deflating the number to do that. Of course, in the base year, that's where they're both exactly the same. Real GDP and nominal GDP are the same number in the base year. That's why you see these two graphs intersecting. So the blue is real, the orange is nominal. Any year prior to the base year, if you're converting to the base year, you're making the number larger. You're inflating the nominal value to get the real value because you're adding in the inflation that happens between that prior year and the base year. Now I've added this equation because remember that example I just talked you through? If you made $50,000 last year, this year you're making $52,000. That's a 4% increase, but that's a 4% increase in your nominal income. What if there was 3% inflation from one year to the next? Then how much did your purchasing power increase? In other words, how much did your real income increase? It's more like 1%, right? Well, I've given you this equation. This is actually not in the textbook, but just so you can sort of see it in writing and understand. So look at the equation in the box there. So your nominal income went up by 4% when you went from 50,000 to 52,000, right? That's your nominal income. So that's on the left side. Look on the right side. So if you have 4% on the left side, and on the right side, I told you the inflation rate was 3% during that time, there's only room for 1% of a change in real income, right? And then down below, I just rearranged because normally you know the change in your nominal income, you know the inflation rate. What you don't know is the percent change in real income. So this is what you do. You rearrange, solve for percent change in real income, and you can see it's equal to percent change in nominal income minus the inflation rate. It's a simple equation, but and your textbook just assumes that you know it, but I wanted to put it down in writing just to sort of make this clear to us. In our next video, we'll get to the heart of this chapter, and that is where we're actually measuring GDP. Our federal government measures GDP in two ways. The first way, the expenditures approach, it's counting up all the dollars that were spent to purchase all the goods and services that were produced in our economy in a year. That's the best way to look at it. If you count up all those dollars, that's the expenditures approach. So if you can recall the circular flow diagram from chapter 3, you're measuring up all the dollars spent in product markets. That's what we're going to spend most of the time on. But then we'll also talk about the income approach. This is where the government is measuring up all the dollars that were paid to everyone who played a part in producing the GDP and were paid some form of income. That's the income approach. That's measuring all the dollars spent, again, the circular flow diagram, in resource markets or factor markets. If you measure it using method 1, you should get the same answer. Measure as if you measured it in method 2. And we will look at one particular year and see how close they came. And I'll see you guys in part C shortly.